So 3.4, graphing linear equations in standard form. We are used to seeing it in slope-intercept form. For standard form, it's going to be ax squared plus by equals c. In other words, your x and your y term are on the same side of the equation, and it's equal to some number. So instead of y equals mx plus b, when it was in that form, we used the y-intercept and the slope to graph it. Today we're going to look at how we graph it using the x-intercept and the y-intercept. So the x-intercept is the point where it crosses your x-axis. So our x-axis is here. Whatever point it crosses, that's your x-axis. Our y-intercept is where it crosses our y-axis, which is this line right here. And that's always going to be when the other variable is equal to 0. So the x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. And we've got two kind of special cases for our graphs. If you just have y equals some number, it's always going to be a horizontal or a straight across line. If you have just x equals some number, it's always going to be a vertical or a straight up and down line. Notice for the first one, y equals some number, there's no x anywhere in that equation. And for our second special case, there was no y anywhere in that equation. So how do we use our intercepts to help us graph it? Well, if you have 2 points, you have enough points to be able to graph the equation. So if I can find this point here and this point here, I can connect those points and draw in my graph. All right, so to find the x-intercept, you're going to actually substitute a 0 in for y and then solve it for x. To find your y-intercept, you're going to substitute a 0 in for x and then solve it for y. Okay, so let's look at our two special cases first. How do we graph just y equals -3? So we're going to go to where y is -3, which is right here. And because it's just y equals a number, it's going to be straight across. Here's another way to think about it. This is the coordinate point 0, -3. This is the coordinate point 1, -3, 2, -3, 3, -3, 4, -3. Notice my y value on all those coordinate points is -3. If you're unsure, if you're thinking, okay, should I go straight up and down or not? Okay, if I were to draw a point here, y is no longer -3 there, y is -2, so that point doesn't work. So it's not going to be a straight up and down line. It is going to be a horizontal or straight across line. If I have x equals 2, I'm going to go to where x is 2, which is right here, and then I'm going to draw my vertical, my straight up and down line through it. And again, everywhere along this point, x is 2. So this is the coordinate point 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, and so forth. So when I am drawing that line, every single x value is 2. Okay, so if we get to number 3, find the x and y intercepts of the graph. So this is where we're going to plug in a 0 for x, solve it for y, then plug in a 0 for y and solve it for x. So I will plug in a 0 for x first. And the cool thing about finding your x and y intercepts is it always makes one of the terms completely cancel out. So then it's just a one-step equation to solve it. So all I have to do is divide by 4, and I get y equals 3. Then I'm going to plug in a 0 for y as a whole separate equation. Okay, so again, one part completely cancels out. I'm left with 3x is equal to 12. When I divide both sides by 3, I get x is 4. So that's my x-intercept, and this is my y-intercept. Okay, try number 4 and 5. See if you can get your x and y-intercepts, pause it, and then come back when you think you've got it. All right, so if I plug in a 0 for x, this term's gone. -4y equals 16. If I divide by -4, then I get y is -4. So there's my y-intercept. Y equals -4. And then if I plug in a 0 for y, my second term cancels out. I'm left with -x is equal to 16, which if I divide both sides by -1, gives me x is a -16. So there's my x-intercept. And the last one, again, if I plug in a 0 for y, or excuse me, a 0 for x is what I did first. This term cancels out, and I need to just divide both sides by -2. So I get my y-intercept is a positive 15. Then if I plug in a 0 for y, my second term cancels out, and I'm left with 5x equals -30. When I divide both sides by 5, I get x is -6. So now here's the cool thing. Once you found your x and your y intercepts, to graph them, all you have to do is plot those 2 points. Okay, so instead of graphing this problem here, I'm actually going to graph number 3. So I found that my y-intercept was at 3. So I'm going to go to where y is 3, and I'm going to put my point right there. Then I'm going to plug in my x-intercept. It says x is equal to 4 at this point right here. So I have my x and my y-intercept. To graph it, I just connect those 2 points. Okay, so instead of graphing this one, I want you to actually graph number 5. So that last one we did. So everybody graph number 5. Okay, so I get y is equal to 15, which is going to be way up here. And I got x was -6, which would be over here. And then I can connect those 2 points. And again, I've got my graph. Okay, if you're extending your graph like this, it would be a good idea to label your points as -6, 0, and this would be the point 15, 0, 0, 15. Let me erase. It would be 0, 15 for my coordinate points. Okay. So you have 2 ways that you can record your x and your y-intercepts. You can record them like I did up here as y equals and x equals, or you can list them as coordinate points. So this is the coordinate point 0, 3, and the other one is the coordinate point 4, 0. Notice one of the coordinate points is always going to have a 0 as part of it because that's by definition how we're finding our intercepts. Okay, take a second and write your summary. How do you find x and y intercepts? And then how do you use those intercepts to be able to graph an equation that was given to you in standard form? You also want to talk about how do you know it's going to be a horizontal line and how do you know when it's going to be a vertical line. So write that summary and then come tomorrow prepared to ask any questions about anything you saw in the video that doesn't make sense.